Hi there. Today we're going to determine the equation of sinusoidal graphs. So we're going to do the inverse of what we did before. Before we were given an equation, we had to graph it. Now I'm giving you the graph, and you're going to have to find out the equation. Now here's the thing. You can model any graph using sine or cos, and we're going to get to that at the end. We kind of figured that out in the last step, step 4. So we won't talk much about that till we get to the very final step, what I mean by you can use sine or cos. But if you remember, they're the same wave, just shifted over. So if I draw just kind of, well, you can see one right here. You know what, let's, instead of me rambling on, let's just wait till we get to step 4 and then I'll show you what I mean. Okay, so let's go through the steps, the things we need to find. So what we need to find, whether we're using sine or cos, it doesn't matter at this point. We need to find A, K, D, and C, right? We need to find all of those. So the A is attached to our amplitude. The C is the equation of our axis. So let's start with the equation of our axis. That's the first thing I like to find is C. Now the equation of our axis is the middle of our graph. So what we got to do is identify, well, where's the top of our graph? Where's the bottom of our graph, right? So the top is right here at 2, right? And feel free to draw on these when you're doing them yourselves. It helps a lot. Maybe this is so easy to find you don't need to draw it in, but I like to draw everything on here that I can. All right, so there's the maximum and minimum. Remember, we also call it the peak or the trough, right? So I'm just going to draw some vertical lines here. All right, so my peak or the maximum, right, is, I like to use the word maximum, peak and trough or whatever. Anyways, the peak is, what do we got there? Y equals, sorry, can't even read my own graph, y equals 2. And the trough, the lowest point, is y equals -4, right? Okay, so we already covered this in an earlier lesson, right off the bat. How do we find the equation of the axis? If you remember, we covered it. It's just going to be, it's y equals the maximum plus the minimum, or the peak plus the trough, divided by 2. Okay, so that's our formula. So in this case, I have 2 plus -4, and we're going to divide that by 2. So 2 plus -4 is -2, divided by 2 is -1. So that would be where the equation of my axis is. Now, here's the trick, and this is where people have a hard time when we get to the last step because they don't do this one key thing. Draw this on your graph. I can't stress this enough. Draw it in. You don't have to draw the lines for the maximum minimum, but you have to draw this line in or you're going to have a hard time. This is, whenever I do this, help people out, this is always the problem here. They don't draw it in, and then I'm like, well, if you don't draw it, you can't find where the sine equation starts, okay? So there is our axis. It's y equals -1. So remember, the equation of our axis is, it's y equals c, right? So in this case, therefore, c equals -1. All right, so we have the first piece of information for our equation, right? And again, the big tip, make sure you draw this on the graph. Even if you draw nothing else on here, okay? Always draw this on. And you'll see why when we get to the last step. Or maybe you won't realize it because I've already got it drawn on, but you'll have a hard time when you get to the last step if you don't. All right, draw on the graph. All right, so make your life easier. And this applies to your physics class too. Again, it's been a while since I've been in a physics class, but this is the same thing. Studying sine waves is really important in physics because we use them to model a lot of things in the real world. And namely, one of the biggest ones is the spinning of a wheel and turning of a wheel. And normally in this class, we would spend a lot more time doing that, but because of the scenario we're in, studying at home, we're probably going to do a little less of that, because I'm trying to trim it down to the essential stuff, and I there's already too much stuff to cover. So we'll do a little bit of that, but not as much as normal, because you can go through that in grade 12. All right, so we got that done. Let's move on to step 2, finding our amplitude, right? Our amplitude is, we've also covered this formula, right? Amplitude, now sometimes you don't even need a formula to figure this out. Hang on one second here. There we go. All right, so the amplitude, you can usually, sometimes it's so easy to figure out, you don't need the equation, but I want to write it out just in case sometimes the numbers are ugly or decimals and you need them. It's the maximum minus the minimum divided by 2, right? So it's going to be, well, what's 2 minus -4 divided by 2? So that gives me 6 divided by 2, which is 3. So remember, the amplitude is always a positive number, right? So the amplitude is the distance from the middle, right, to here, to your axis, or from your axis to the bottom, right? From top to the axis or bottom of the axis, right? Which is 3 steps. So of course you could just count it, 1, 2, 3, right? 3 steps, 3 units. 3 units is really what I should say. All right, so there's our amplitude, right? All right, I'm just going to leave that drawn in down here. I'm going to be drawing a lot of stuff on this, so I'm going to try and keep it as neat as I can because this is really key getting this first one really neat. Okay, so our amplitude is 3 units. Now we don't know what it is. It's not a real world problem. Is it 3 meters, 3 what? We don't know right now, so we're saying 3 units. Okay. All right, so we got those 2 pieces out of the way. Oh, we got to stay. Okay, so what's A? So remember, so A is the amplitude, right? So A equals 3 in our equation, right? That's the vertical stretch. The amplitude is how much have we stretched this thing vertically, right? And C is how much we've shifted it vertically up or down, right? So we got basically the things that affect our y coordinates out of the way. The shift up or down, which is what this is, our translation. I'm just going to write that here. This is, remember, our vertical translation. You know what? Let me just write that up here maybe. VT, vertical translation, right? And the A is our vertical stretch. Now, if you remember, A can be negative. So I'm going to make a little note here. A can be negative. We're going to leave it positive for now, but I'll show you at the end, at the very end, how you could make A negative if you wanted to, but we'll wait to the end. So it can be negative if you want, but for now, let's leave it positive. But we could make it negative, but remember what that would be doing is flipping this, and I'll show you how we could use that a little later, okay? For now, it's easiest to leave positive when you're first learning it, okay? All right, now moving on. We gotta get into the things that affect the x coordinates, right, when we're graphing it, which is the period and the phase shift. All right, so to find the period, hang on, let me just move this up here. I need a little more room. I'm trying to squish everything on one page. Let me just move this up here so I got a bit more room. Okay, determining the period. All right, let me just draw a line in here just to kind of, I can't imagine how fun it is to sit there at home and listen to me ramble on. I'm sorry. I'm doing the best I can. I know this is not ideal, and I'm sure if I were you, I'd be rolling my eyes listening to my teacher ramble on about this stuff. So sorry if I'm boring you to death. Okay, so finding the period, to do that, what we're doing is, if you remember, what is the period? We need to find the length. Find the length of one cycle, right? How long is it? Length of one cycle. Now you can really measure this from anywhere, right? It doesn't really matter where you measure it from. But usually, I'm not going to say always, but usually it's easiest to just start at 0. So usually easiest to start from 0. That's where I generally start, unless I'm really stuck figuring it out. So we might run into one a little later. I'll show you. This first one, I'm going to take my time, really go through it in detail, and then the next couple I'll kind of fly through a little quicker. Okay. All right. So what do I mean to start from 0? Okay. So let's start. Here's 0 right here, right? There's 0, right? So let's start. I'm going to highlight it. All right, so starting right here on my graph, right? There's 0, so we're starting on the y-axis, right? That's what I mean when I say start from 0, starting on the y-axis, right? Because we're looking at the x-coordinates now, right? How long does it take to do one full cycle? All right, so I go down, I come back, I go up, and then I come back, and then it repeats again, right? That's one cycle. So there is one cycle of this thing. So let me just kind of be as detailed as I can here. All right, so from here to here is one cycle, right? All right, one cycle. So how long did it take to do one cycle? From 0 to pi. So that means it's pi. So that's why it's easiest to start at 0, because from 0 to pi is pi. Whereas like if we had measured from, say, I don't know, here to back here, well, what is this number? What is that number? It can get a little tricky, right? So it's easiest, usually, not always, but usually easiest to start at 0, okay, and to figure that out. All right, so our cycle is pi, right? That's what it is. The period, I should say, one cycle is period is pi. Now, that's if we're doing in radians. What if we want to do in degrees? So let's write our degrees on here again, right? So what was pi? If you remember our unit circle, right? Pi, 2 pi is a full circle, right? Which is 360 degrees. So pi is half a circle, 180 degrees. Right, so I'm just going to kind of write this in. That means pi over 2 is 90 degrees. I'm going to write in a few of these so that way we can talk about both. Again, when we really get good at this stuff, it's all about radians. But it's okay right now to work in degrees. So each pi over 6 is 30 degrees. So 30, 60, 90, 120. What else we got here? I can't count. 150 and then 180, and that'll do for now. So if it helps, write the degrees in while you're getting better at this stuff, okay? But for those of you that really want to get good at math and really want to pursue subjects that require math, right? Engineering, physics, any kind of computer science, anything like that, right? And all the other science fields, you're going to have to really kind of step up your game, and don't be afraid to just learn these radian measurements. It's not that hard. You'll get better at it. Just don't be afraid to keep trying, okay? All right, so now we've figured out that the period in this case is pi, right? So let me write that down here. This is the period. Period is pi, or 180, right? Or 180 degrees, depending on whether we're using radians or degrees. Now, here's the deal. What is K, though? So we have to go back to the formula we learned before. And again, this is from the previous lesson. Period is equal to 2 pi over K. Or, if we're going to use degrees, 360 degrees divided by K. So I'm going to do both. That way you can see both, right? Now, what if we want to isolate, because we're looking for K now, right? We're not looking for the period. We have the period. We need K because that's what we need in our formula. So all we're going to do is let's just switch things up. Let's multiply both sides by K, divide both sides by the period. So if the period equals 2 pi over K, well, therefore, K would equal 2 pi divided by the period. I'm just rearranging my formula, right? Or 2 pi divided by 360. Oops, sorry. Or not 360. What am I doing here? It's 360 divided by 2 pi. All right, my bad. There we go. 360 divided by the period. There we go. All right, so depending on whether you're using radians or degrees. So in both our cases, what are we going to get for K? In this case, if K is pi, right, because that's what we got, I go, well, what's 2 pi divided by pi, right? What's K equal to? 2, because the pi's cancel out. So there you go. What if I decide to use degrees instead, right? Okay, so K equals 360, sorry, I'm getting to the edge of the screen there, divided by 180. Well, what's 360 divided by 180? 2. So perfect. Look, you get the same value for K no matter what, whether you decide to use degrees or radians. We should get the same thing. Perfect. All right, so what is K again? Remember, K tells us our horizontal stretch, right? How far we're stretching it left or right. So this thing, right, whether we stretch it or whether we're compressing it, right? All right. In this case, we've compressed it because remember, normally it takes 360 degrees to do one full cycle, but ours is only doing it in 180 degrees, so we've shrunk it, right? So it's been compressed. All right, so far so good. What are we moving on to now? Let's see, the final step. And here's where things, I don't want to say get messy, it's just that we have a lot of options. I want to move this up because I'm going to need a lot of room here. All right, so we're going to assume we've got everything here, move it up as much as I can. All right, I'm going to need all the room I can down here so I can get a really good, complete note. In fact, if you don't mind, I'm going to erase all of this stuff here so I can use the whole bottom of the page. So let's just remember when I erase it, right, what did we say the equation of the axis is? -1. What did we say the amplitude, or A, I should say, is 3. So I'm going to pause and erase all that stuff, okay? Okay, I've cleared up the page. I've gotten rid of everything else. We have our key information down here, right? We've already figured out what C is, what A is, what K is. Now the last thing to figure out is what D is. And it's not that it's difficult, it's just that there's a lot to talk about here, okay? Now, when we're determining D, I'm just going to be writing everywhere for this. D is our phase shift, also known as our horizontal translation, right? That's what that is. How much we're going to move left or right. How much we've shifted this thing left or right. Now, here's the first catch for D, okay? When we're finding out D. There are infinite possibilities. Now, we'll talk about why. That's the whole thing, okay? Infinite possibilities for D. Because this thing just repeats over and over and over again. Possibilities. There we go. Okay? It repeats over and over and over again. So it means there's infinite places to start when you're doing sine or cosine. All right, so I'm just going to move this. Let's just move this over here so I got lots of room. Okay. Let me get rid of my peak and all this stuff so I got lots of room to write here. All right, so here we go. So let's start with, what if we're talking about sine? Okay, so let's use sine to start. All right, so if I'm going to use sine, what does sine look like? You got to remember what the basic graph of sine looks like, right? The basic graph of sine looks like this. It starts at 0. It goes up, down, and back. That's sine, right? So sine hits the axis at 3 points, the start, the middle, and at the end, right? So it starts on the axis. This is key, okay? On the axis, right? And from there, it moves up, okay? So that's what sine does, starting on the axis, moving upwards in that motion. So that's what we're looking for. So if we're going to do sine, let's start with sine, right? Where do we see that? Where do you see it starting on the axis, moving upwards, right? Well, I see it here. There's a place, right? So you know what? Let me erase everything else off this graph. Let me clear it all off so I can really just focus on this right now. All right, so I've cleared up a lot of stuff. I got rid of everything just so we can focus on sine. So looking for that pattern. So let me highlight that pattern. Look, here's sine, right? Goes starting on the axis, not on 0, starting on the axis. That's why we need to draw that axis in. That's why I was so repetitive about draw the axis in at the start. Look, it goes, starts on the axis, goes up, down, and back. So we're looking for that starting point. So what's that starting point? So, let me write this in here. What was I saying? It goes going upwards, right? Goes up. All right. So D could be, now it depends on what I'm going to write both the radians and degrees, right? D could be right here, right? It starts at 90 degrees, right? So if we're going to do degrees, it's 90, or if we're going to do radians, it's pi over 2. So it could be pi over 2, or I'll just write below 90 degrees. That's one of them, right? There's one starting spot for it right there. Where else could it start? Oops. All right, so let me just, there we go. Let me erase this. There's one spot. Where else do you see it starting on the axis? Because remember, it just keeps repeating. So basically, wherever it ends is where it also starts. How about right here? Now, we don't see the full graph, right? But there's that pattern. Look, it's starting again, going up, down, and eventually it'll come back up. So there's another spot, right? It could be over there at 3 pi over 2. Right? Or what is 3 pi over 2? Well, let's see. If that's 90, right? 120, 150, 180, right? Basically, we're just going to add. What was our period? Remember how our period was pi, or our period was 180 degrees? Well, what's 90 plus 180 degrees, right? 90 plus 180 is 270. So that's 270 degrees. That's what that is, right? So it could be at 3 pi over 2 or 270. Now again, if you're also having trouble and you forget, remember how you can convert. So if you have 3 pi over 2 and you're like, what is that again in degrees? All I got to do is times that by 180 over pi, right? So you can take any of these and convert them. The pi's cancel out. I go 3 times 180 divided by 2. I'm going to get 270, right? So that's another way of finding it, okay? So there's another spot where sine starts. There's another spot on this graph where it starts, right? It could start back here, right? Look, isn't that another place where it starts on the axis, goes up, down, and back? So there's a third spot, right? So basically there's 1, here's another one, 2, 3. Those are just the ones we can see. So remember how I said there's infinite? Because it keeps going. So this graph keeps going. We could find another place it starts and another place it starts. We're looking for that pattern I've highlighted, right? So I got, 3 spots I've highlighted. This one in blue, this one in green. Here, I'll do this one in a different color there, right? It just keeps starting and repeating, right? So it starts here, it starts here, it starts here, and then it repeats. So another possibility would be the negative one. I didn't give myself some room. I wish I had put it behind this here. I'm just going to move these over here. Let me pause and then write the negative one. All right, there we go. So what is this right here? It's negative pi over 2, right? Well, what's negative pi over 2 right there, right? Negative pi over 2 is negative 90 degrees. All right, so negative pi over 2. And this keeps going. So we could find a bunch. So there are 3 possible places. So that means when I write this equation, I could have, there's 3 that I can see on the graph, but there's even more, right? So when we write this equation, here's what it's going to look like. Y equals, okay, let me just write out what we have up here. And then let's substitute everything in. Y equals a sine of k, x minus d plus c. Now, depending, do we want to write in radians or do we want to write in degrees, right? Okay, so I'll write them both. So I'm going to write a lot of different possibilities out here for what it could be, right? But they all mean the same thing. So let's look at some different radian ones, right? If I want to write in radians, okay, I could write it like this. Y equals a, which is 3, times sine of k, which is 2, x minus d. Now, here, I'll fill that in last, plus c. And c is negative 1, so plus negative 1 minus 1. So all we got to do is to fill in this spot here with one of these. We could put negative 2 in, pi over 2, 3 pi over 2, or if we want to do in degrees, these, right? Now again, usually we use radians. So it's minus whatever this is. So it's x minus this. So if I'm going x minus negative pi over 2, it would become x plus pi over 2. So there's one of them. Now the equivalent would be, if I did in degrees, I'll just write it below, plus 90 degrees, right? So I could do the same thing just using that. So there's one example. Or I could write y equals 3 sine of 2 x minus the next one, pi over 2, right? Like this, minus 1. Or, you know, the same thing, but instead of minus pi over 2, minus 90 degrees. And here's a third one, right? 3 times sine of 2 times x minus 3 pi over 2. Minus 1. Or, instead of minus 3 pi over 2, minus 270, right? So there are technically 6 of them. I just didn't write out all 6. I just wrote the degree underneath. But there are 3 possible equations for this, okay? Using sine. All right. Now, let's get into cosine. So we're going to kind of do the exact same thing now, but with cosine. And we can find a graph of cosine. So I'm going to erase all this, and then let's do the exact same thing, but finding 3 possible graphs for cosine, all right? So let me pause and clean this up again. All right, so if we're going to do cosine now, we got to think about first, what does the cosine graph look like? We have to identify that first. We got to know this. So that's why I say these are 2 patterns you should really know. Cosine starts at the top, right? So cosine, remember how it started like this and then went down and then back up, right? So cosine starts at the top, hits the bottom, and then hits the top again like that. That's basically where its start, middle, and end are, okay? So cosine starts at the maximum. Starts at the max, okay? And it starts by going down, okay? No, let's go going down, okay? So starting at the top, going down. So let's have a look. Where do you see it starting at the max going down? I can see 3 different spots, right? I can see it right here, right, going down. I can see it right here, heading down, and I can kind of see one just starting right here. I can't see the full thing going down, but there are 3 cosine spots. So let me kind of highlight them. There's the first one, starting at the top, heading down, and then heading back up. So there's 1. How about this next one? 2, starting at the top, heading down, coming back up, oops, right? And then we get just a little peek at 3 here. It's just starting, right? So to do cosine, we need to figure out what is that number at the top right there. Now, this one's a little trickier because, look, it's right in between, right? But we can figure this out, right? We got to figure out, well, what's in between, you know, here and here, right? Well, let's just go back. How I do it is I go back up my scale, and I look at, let me just do this in a different color here. I say, well, if this is 30 degrees from here to here, or pi over 6, right? Well, what's half of pi over 6, right? Let's cut that in half, because that's what we are when we're on the halves. Half of pi over 6 would be pi over 12, or 15 degrees, right? Okay, so that means every half is 15 degrees, like 15, 30, right? 45, 60. So just go back to the very start of your scale to figure that out, right? Instead of staring right here and saying, well, what's that, right? Now you could do that too. Like basically what's between 120 and 150. You could think about it that way also, right? What's the halfway point? So it's every half is 15 degrees. So in other words, this between 120 and 150, the halfway point there, if I just write in degrees here, hang on, let me erase this and just kind of clean this up a bit. Here, it's really supposed to come down to here is where I want this line to come down, right to the halfway points. There we go. Okay, so if we're going to do it in degrees, it would be 120 plus 15, 135 degrees, right? Now what about in radians? Well, each of these is a pi over 12, right? So let's count pi over 12s. 1 pi over 12, 2 pi over 12, 3, 4, 5, 6, 7, 8, 9 pi over 12, right? Well, 9 pi over 12, let me get rid of that, right? What does that reduce to, right? 9 pi over 12, right? Reduce it, that's 3 pi over 4. So this right here would be 3 pi over 4. So I just counted by 12ths, right? And how did I know it was 12ths? Well, I just said, what's half of pi over 6, right? Half of pi over 6, cut that in half is pi over 12, right? What's half of a half? A quarter. What's half of a quarter? An eighth, right? I'm just doubling the denominator, right? So there you go, 3 pi over 4. So there's our first possible value for D. So let's write down some different possibilities. Or maybe that's our middle one, right? What did we say? 3 pi over 4. If we're going to use radians, or we said that's 135 degrees. All right, let's go backwards, right? What if we count backwards by 15? So like negative 15 degrees, negative 30 degrees. This would be negative 45 degrees. Right, so a big part of this is you learning to count on a scale, learning to read the scale, learning to chop the scale up. That's a big part of this. So if you're like, hey, this is tricky, that's the point. That's the hump you're getting over and learning, right? That's what the skill you're supposed to be developing here, right? It's not necessarily going to come to you immediately. So you got to look at the scale, chop it up. And I always just go back to 0. Whenever I chop it up, I go to 0 and I look at my first labeled coordinate, right? They labeled pi over 2 and 30. Okay, I can cut that in half, right? Make it 15. I can cut that in half. I can start chopping this thing up, right? Chopping it up into thirds or halves or whatever that I need to chop it into. All right, so if that's negative 45 degrees, how many pi over 12s did we go backwards? 1 pi over 12, 2 pi over 12, 3 pi over 12, right? I went back 3 pi over 12, which if I reduce that, right? What's 3 pi over 12? Reduce it, divide both by 3. That's pi over 4. So this would be negative pi over 4. All right, so we found another one. All right, so this would be negative pi over 4 or negative 45 degrees. Now, I totally get, again, that a lot of you are like, man, the degrees are so much easier, for sure, but keep working on those radians, okay? All right, let's just find one more here. So what is, this one right, where are we at here? Right here. This guy right here, right? What are we at right there? Well, we can keep counting by 15s if we want, like 15, 30, 45, 60, yada, 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 right? Long story short, we know this is 270 because I already labeled that. So what's the next one going to be? Another 30. That's going to be 300. And then what's 300 plus 15 more degrees, right? So right there, because that's 1.5 squares, right? What did we say? 300 plus 15? That's going to be 315 degrees. All right. What is that in radians? Well, how many pi over 12s have I gone? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 pi over 12. Well, we can divide those both by 3 and get 7 pi over 4. So there you go in radians, right? Now again, obviously I've done this a lot, so maybe it's a little quicker for me. It takes time. Take your time. Think about your scale. What do you want to cut it into, right? What makes the most sense for where this point is? That's what we got to figure out where that is. Well, I'm right in between. I'm on the halves between these, right? So that's why I went back to the start and said, okay, what's halfway between my first 2 points, right? All right, so 7 pi over, what did I say, 7 pi over 4, or what did we say it was? 315 degrees. All right, so if you're going to do cosine equation, there are 6 possible, answers. 3 in radians, 3 in degrees. So if we're going to write this out, it's the exact same stuff as the sine except for d. The only thing that's different is the d. So a cos of k, x minus d plus c, y equals 3 times cos of k is 2, x minus, now the only thing that's going to change is that. All we change is the cos and what we put in for d. The c is still the same, everything's still the same, right? So all that's different is what are we going to put in here? So I could put this, I could put this, I could put this, or if I wanted degrees, one of these here, right? All right, so I'm at, the first one, what is x minus negative pi over 4? It comes x plus pi over 4, right? Or what's x minus 45 degrees? So inside your bracket, you could have x plus 45 degrees, right? If you want to write in degrees. So when you do your homework, I'm going to kind of say, like, write 1 for each, right? 1 degree, 1 radian. There we go. See? So there's the same thing, 1 written in radians, 1 written in degrees. And we could do the next one, right? We could write a whole bunch here. So I know this is kind of a pain because there's so many possibilities, but that's also kind of the point of a sinusoidal function. It keeps repeating the same pattern we could use. So if you put any of these equations I'm giving you, if you put them into a graphing calculator or you went on to desmos.com, that graphing website, oops, that should be a minus up there. I wasn't paying attention while I'm talking, right? That should be a minus. X minus 3 pi over 4, x minus 135 degrees. If you put any of these in, it's going to draw the exact same graph. It just basically starts. It chooses this as its starting point, or it chooses this as its starting point, but then it extends it in both directions. So it doesn't matter. It just keeps filling it in. So it really doesn't matter. We could make this, like I said, there's infinite possibilities. We could keep going, right? And picking more and more and more. But they all draw the exact same graph. All right, might as well finish it since I'm going here. All right. All right, so there we go. So there are some possibilities, right? What do we got here? 3 cos 2 x minus 315. Oops, 315 degrees. minus 1. All right, getting a little sloppy there, but there you go. So lots of possibilities, right? So, all right, so there you go. I know I've been talking for a while. It's already almost a half hour of this video, but I'm going to do a few more examples for those of you who want to see a few more examples. If you feel like now you got it down pat, you get the whole idea, cool, move on, try the homework. But I'm going to do a couple more just to, give you some more examples. I'll do them a little quicker, though, this time now that I've explained everything. I won't go into as much detail. Okay, so we got another graph here. Let's try and find one sine and one cosine, right? Because we can go on all day finding a bunch. All right, so let's go through. First thing I like to find is what is C, right? Let's do that over here. Let's do it down here. All right, so C. To find C, we need to find the axis in the middle, right? So where's the middle? So again, you can use the equation, or you can just, count on the graph and figure it out. But remember, the equation is what's the maximum, which is 4, plus the minimum, which is -2. Divide that by 2. So we are going to get 1. And I would strongly suggest you draw that in, as it'll make finding the equation for sine much easier. All right, so there is my middle. Y equals 1, which means C is equal to 1 when we write our equation at the end. So let me just highlight that there. All right, so I can find it easier when I'm doing that. All right, next thing, let's find the amplitude. All right, so to find our amplitude, which basically means we're finding A, right? That's what we're looking for here. And we use our amplitude formula, or you can just, count and figure it out, right? What's your distance from the middle to the top or middle to the bottom, right? So the amplitude is you just add or you take the max and you subtract the minimum, and you divide it by 2. So our amplitude is 4 plus 2, which is 6, divided by 2, which is 3, which means A is 3. I didn't talk about on the last one how we can make A negative, so maybe I'll show you on this one how you can do that if you would prefer to make A negative. All right, so there's our second piece of information. Those are pretty easy to find. Everyone should have no problem with that. All right, getting a little trickier. Now we need to find our period. So that's going to help us find K. All right, so the period we need to find, and now you can start this anywhere. You just need to figure out how long is it from start to finish for one cycle of this thing, right? So I'm not really focused on sine or cosine. I don't really care right now. I just want to know from any starting point to any ending point, how long is that, right, for one cycle? So I always just start at 0 here, and I say, all right, well, starting right here at 0, right, there's 0 on my y-axis, right? How long does it take? Okay, so I'm just going to start right here. Oops, I go up, down, right, and back. There we go. Oop, I went too far, didn't I? Because I should have stopped right here. Went a little bit too far. Let me just redraw that there because I'm starting. This is always the trickiest part too, I think. A lot of people say, well, are you looking for sine or cosine? I'm like, I don't really care right now. I just want to figure out how long is it from 0 to where it starts repeating again. Look, from here to here, right? Wouldn't you say that then it starts repeating again? So I don't really care whether it's sine or cosine, right? I'm just saying, okay, my period is from here to here, right? It's pi again. Looks like we got pi again, right? Because look, that's the length from there to there. So the period is equal to pi, right? Or if we're going to do degrees, that's 90 degrees. And maybe that would have been a good idea right from the start also to write in that. But let me just get this right here. All right. So again, another good idea. So we said from here to about here, right there, right, is one cycle, one period, right? And then it repeats. So we're not really zeroed in whether it's sine or cosine because it could be either or. It doesn't matter. I just always start at 0. And how long does it take till it starts the pattern again? So everything I'm going to give you is going to end somewhere where we can figure out the number. Now, each of these pi over 6s is a 30 degrees, right? Oops. And you know what? Pi is not 90 degrees. If some of you are shaking your head at me, it's 180. Right? Now, again, if you're like, how do I remember that? Remember, take pi or take whatever it is or take pi over 6. You just times it by 180 over pi, right? So that cancels out. I get 180. So that means that's 180 there. Or pi over 6, right? Pi over 6. Oh, what is that in degrees again? I'm just going to times it by 180 over pi, right? Pi's cancel out. 180 divided by 6, right, is going to give me 30. So there you go. So it looks like this scale is by 30 degrees or pi over 6s, right? So 30, 60, 90, pi over 2 is 90, right? 120, 150, 180, keeps going. We can write in some more if you want to. Oops, I'm screwing up here. 210, nope, 240, 270, 300, and so on and so forth, right? Okay. All right, so we've got our degrees and our radians on there. Now, to find k, remember, what do we got to do? So period is pi or 180 degrees. Okay, so to find k, remember we've switched around that period formula. It said period equals 2 pi over k. That means k equals 2 pi divided by the period. Or if you're doing degrees, 360, because that's a full circle, just like 2 pi is a full circle, divided by the period. In both cases, we'll get the same thing, because we're going to go, well, what's 2 pi divided by pi? Or what's 360 divided by 180? And we're going to get the same thing for k again as we got before, right? Now, sometimes you might get a fraction, like a half or something like that, too. All right, so we're going to get 2 in both cases, right? All right, so we got that. Okay, so we got those, the 3 easier parts. The first 2 are super easy. K's takes a little more work to find. You got to take your time, kind of trace with your finger, draw on the graph where it's at. Now it's time to figure out the trickiest part, which is D. I don't even know, is this really the trickiest? K is probably where people have the most trouble. All right, which is called our phase shift, right? Also known as our horizontal translation, how much we move this left or right. So how much was this graph moved left or right? Because normally they start at 0, right? But where does sine and cosine start? Okay, so to do that, we need to find different D values. So let's say, sine or cosine. I'll do the cosine down here. So remember, when you're looking for sine, we're looking for starting on the axis, going up, coming back. That's the pattern we're looking for, right? Starting here. Whereas when we're looking for cosine, we're looking at the top, going down, and then coming back, right? Starting at the top, hitting the bottom, coming back. So let's do a couple for sine. Where could sine start? Starting in the middle, right? Sine could start right here, right? Going up, down, and back. Or it could start right here, right? Up, down, and back. Okay, so there's 2 that we can spot right away, either at 30 degrees, pi over 6, or 210 degrees. So let me get rid of all this junk here. And I'll just label it a little nicer here, right? Sine could start right there, or sine could start right there. So for sine, we can make D into pi over 6, or 30 degrees, or we could use, what did we say, 210 or 7 pi over 6. All right, so there's 2 possibilities for D. So if I want to write this out, right, we're just going to fill in all the blanks. Y equals A sine of K x minus D plus C. So let's just fill everything in. We already know A is 3. We know K is 2. X minus D. Now this is where we got to choose what we're going to put in there. Plus C is plus 1. Now, I could put a bunch of different stuff in here, right? I could put x minus, let's say all the different variations. It could be pi over 6. Or I'm not going to write it out a bunch of times. Or I could write in 30. So if I say, give me 1 degree and 1 radian, there you go. There's 2 different ones, right? You'd write the whole thing out. Or it could be 7 pi over 6. There's another radian one. Or it could be 210 degrees, right? So everything else is exactly the same. Like I don't know if you want to watch me write all 4 of these out, but they're all going to be exactly the same, right? All that's changing each time is the possible value for D. Okay? And again, why can it have so many? Remember, it just keeps repeating this pattern over and over again. So it doesn't matter which starting points you use. If you punch this in a graphing calculator, or you try to graph it yourself and then you extend it, you get the exact same picture. So there's 4 possibilities, 2 radian, 2 degree ones. All right, let's do cosine now. Same thing. Then remember, with cosine, C, A, K are all going to be the same. It's just the value of D is going to change. So for cosine, we're starting at the top. Going down, right? So like this, starting at the top, going down, coming back up. There's 1, so we could start right there. Or 2, starting at the top, going down, coming back up, right? There would be another one, okay? So if we're going to do cosine, let me just label these. These are the sine starting points down here, right? And these are the cos. I'll just write cos for short instead of cosine. Starting points there. All right, so now we're going to have to figure this out. We're going to have to be a little bit more clever here. Cos is starting in the middle. All right, well, what is in between 60 and 90, right? That's the thing. We need the halfway point. So it's going to be, right, 15 degrees halfway in between, right? Because half of 30 is 15. So every halfway point on this graph, we're going by whatever the scale is on the graph, is 15, 15, 30, 45, right? 60. So 60 plus another 15 degrees would be 75 degrees. So there's one possible value for D if we do 75 degrees, right? Now, what if we want to do radians? Well, this is the same as before. What's half of pi over 6? That's pi over 12. So 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, right? So this would actually be 5 pi over 12. Let me make sure I count that right. 1, 2, 3, 4, 5. Yep. So we could do 5 pi over 12 or 75 degrees, right? So there's one possibility. What about way over here, right? Where's our halfway point right here, right? Oof, sorry. So what do we got there? That's 240 and 270. All right, so we know every half is a 15 degrees, right? So 240 plus 15, right, is going to be 255 degrees. So there's another one in degrees, 255. What if we want to do it in radians? Well, we know every halfway point is a pi over 12. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's 17 pi over 12. So I just went back to 0 and counted over, right? 17 pi over 12. So a big part of this isn't just finding the equation. It's also, again, getting you used to counting on the scale, figuring this out, right? So if we're going to do cosine, it's the same thing, right? Start with your basic one, which is exactly the same as sine, except it's got the word cos in it. And all that's going to change is the value of d. Where does cos start? Because everything else is the same. So it's still going to be 3. It's still going to be k is 2, right? It's going to be x minus whatever. C is 1. And all we're going to do is just replace this right here with the different possible values. So it could be 5 pi over 12. Could be x minus 75 degrees if we want to do it in degrees. It could be 17 pi over 12. Oops, not plus, minus. 17 pi over 12. It could be 255 degrees. So look at all these possibilities, right? And again, you can write them all in. So we've come up with 8 different equations. All 8 of these, if we punch them in, all 8 of them will draw the exact same graph. It just depends on our scale, whether we're using radians, degrees. So really, we have 4 different ones, right? 4 in radians, 4 in degrees, okay? All right, so there's that one. Let's see, do we want to do another, or are you, I think you're probably getting the point at this point. You know what? Again, you might be done. You might be like, nah, I'm cool. I'll do one more for you for those of you that want it. I know it might be a small group of you, but I'll just do one more, okay? And then I'll let you, get to the home. All right, so let's start this out again. Let's go through all the stuff we need to find. Let's start with C, because that's the easiest one to find. C and A are C and A are really simple, right? So this is our axis in the middle, right? So what do? Add the maximum, add the minimum. Now this one, it looks like it's on the half. So I'm gonna say this is the top, we're gonna say is at 2.5. I know it looks like it's a little, or sorry, no, that's not 2.5. What a weird scale here. Let's see. This is 3 in the middle. So this must be 3.5. All right, so we're going to go 3.5. This scale is not labeled very well, right? And if this is -1, right there, this must be -1.5. All right, so we're just going to use decimals for this. All right, so our maximum is 3.5. Our minimum is -1.5. Add those together, divide by 2, and what are you going to get? I'm going to get 2 divided by 2, which is 1. All right, so the middle is at 1. So let's label C at 1. And let's draw that in. So 1 right in between, oops, there we go. Right in between 0 and 2. There's our middle. Very important to draw that in. Okay, so there's 1 right there, right? Okay, so this one's a little trickier because of where these points are and the scale's not super well labeled. We have to kind of draw it in ourselves to figure it out. All right, so we got that. Let's go on to the amplitude, which is going to help us find A. All right, so the amplitude equals the maximum minus the minimum, so 3.5 minus -1.5. Divide that by 2, so that's going to give us 5 divided by 2, right, which is 2.5. All right, so let's make A 2.5. And you know what? I'm just going to keep leaving all of these as positives. We won't get into the negatives till maybe the next lesson. We'll save that because this is enough as it is. If you can find them this way, you're doing great. All right, so now we got to find the period. So I think this is where the first real frustration comes in as I recollect on doing this stuff in the past with people. So the period, how long does it take to start one cycle? You can figure this out from anywhere. You can figure it out from top to top, right? Or I can figure it out from like here to here, right? Although it's kind of cut off, so I don't see where that is. You can find it from anywhere, right? You want to find it from right here to right here, right? Look at, there's one cycle, right? But what's the disadvantage of that? Well, I have to figure out what this is, and then I have to figure out what this is, and then I got to figure out the distance between those two, right? Well, that's a little trickier. It's always easiest to just start at 0, right? When I start at 0 here, right, starting at 0, right, I go, I'm not worried about whether it's sine or cos, just starting at 0. Okay, this thing goes up, down, and it looks like it's going to go, let's see here, right, I think I've lied to you about how easy this one's going to be able to find, because look how tricky this is. It goes off my graph. I can't quite figure out what that number is. So it's a bit of a problem even counting from 0 here, because right, to finish this thing off, right, it's going to have to, oh no, I lied. It finishes right here. You know what? I'm confusing myself even. I'm proving why this is tricky. I'm confusing myself, not paying attention to where it's, so look, we're starting right here, right, kind of on its heading upwards. It goes there to there, and it ends right there. That's actually would be one cycle, right? So there you go. It's 2 pi is one cycle, from 0 to 2 pi, which means the period is going to be 1. Why? Because isn't 2 pi, or sorry, the period is going to be 2 pi, or 360 degrees is what I meant to say, right? Because 2 pi is a full circle, 360. So, in other words, k, right, or sorry, period is, let's write them both out here, is 2 pi, or 360. We're talking about a full circle there, right? So remember, how do we calculate k, right? We inverted this around. We said, all right, k is 2 pi divided by the period, or 360 divided by the period. There we go. So that means k is, what's 2 pi divided by 2 pi, right? Or 360 divided by 360. This is why k is going to be 1, right? There is no horizontal stretch, right? So no matter what, k is 1. Okay, so it hasn't been stretched because horizontally, because that's our normal starting period, right? 360 degrees, a full circle, or 2 pi. All right, so we got that. Now let's get into figuring out what d could be, right? So d, which tells us our phase shift, which is another way of saying our horizontal translation. Phase shift. All right, so here we go. All right, so let's start with sine again, right? What does sine look like? Remember, starting on the axis, going up, coming back. Getting used to that pattern is a pattern to know. Someone says, what's that you're going to have in physics and grade 12 math? That's the first place to start. What does sine just look like, right? All right, so you know what? Let's just find 1 for sine. So look, right here, starting on the axis, going down, coming back. There is 1 cycle of sine. We're not going to find a whole bunch because the other ones are off the graph anyway. So there's where sine starts, right there. Well, we're halfway in between again, right? So we're going to have to cut this in half, right? There's pi over 6. What's half of that, right? So remember, if we're going to do degrees, pi over 6 is 30 degrees, which means halfway is 15. So this must be 45 degrees, right? Or every pi over 6 cut in half, is pi over 12, right? Because that's half of pi over 6, right? We're just doubling the denominator when we're cutting in half. So 1 pi over 12, 2 pi over 12, 3 pi over 12, right? Well, 3 pi over 12, let's reduce that, right? What's that going to be? Pi over 4. So we can make d into 45 degrees, and 45 degrees in radians is pi over 4. All right, so let's write this out. Y equals a sine of k, x minus d plus c. Y equals, what is a again? 2.5 times sine. K is going to be 1, so I'm not going to bother putting anything there. X minus 45 degrees, we're going to do in degrees, plus c is 1. Or if we're going to do in radians, everything's identical. We're just going to change that measurement, to radians. Alrighty. So again, I know I've said it 100 times. I know the radians tend to suck when you're first learning, and nobody likes that. But challenge yourself to keep working on them and getting better at them, even if you're just converting, right? The more you convert, the more comfortable you're going to get with it, okay? It's really important. Normally, if we had been in class, we'd be really hammering the radians a lot more than I am right now. Which is not me trying to be a jerk. It's me trying to prepare those of you that are going to university level math and really want to, do well. Okay? So, I mean, that's what this is all about, right? I get how like preachy and like silly it sounds, because when I didn't care much at all when I was your age. I didn't really develop a real interest, I suppose, real sincere interest, a personal interest in my knowledge and learning till I was hit second year university, and something clicked. I just kind of matured. I gained an interest. A lot of it came from, moving out and being on my own. And once I was on my own, I really started realizing this is up to me. This is my life. It's not about a teacher barking at me, telling me to do this. It's not about how good my professor is or not. It's about, I wanted to learn. I wanted to get better at it. I just developed this personal drive for a variety of reasons, right? So it's the same thing with this, and it's hard when you're younger for someone, I know, to bark at you and say, you do this, do that, right? But I don't know. I hope you develop some interest in it if this is something that you're interested in, right? All right, so let's do cosine, right? So cosine starts at the top. So I only really see one spot right here starting at the top going downhill, right? So where is that, right? So it's right in the middle. So let's count by 15, 30, 45, 60, right? Let's just count by 30s till we get, or you can keep going, right? But on the 30, 60, right? 90, 120, and then 15 more degrees from 120, right? So that's going to be 135 degrees. So D could be 135. Or in radians, let's count by pi over 12s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 pi over 12, right? 9 pi over 12, well, we can reduce that to 3 pi over 4. All right, so there you go. Sorry, I know I'm turning into an old man. Maybe I'm way past being an old man, I guess. It's already happened. But I don't know. I really developed a real sincere interest in my education. It took me a while longer. I always did okay in school, but it's something special happens to those of you, at least it happened to me and I've seen it in others, when you really actually care and school becomes, it's not just school, it's learning. It's about developing yourself. It's not about just getting a mark. Generally, really good marks come when you care, right? So you can't make someone care, That's what I found with me. I of course I got really good marks when all I wanted to do was do well and study, and I really wanted to learn it. The marks are secondary. They come automatically. That's the point. Good marks come when you really care. Now, when you're high school or grade school and you're just developing the school, sometimes it's difficult. I get that. You're working your butt off and the marks aren't there. But as you progress in university and you've really developed some of those skills and you continue, you'll probably find, for those of you that have a sincere interest, not a fake interest, a real interest, you'll always be getting good marks. You might be having stressful nights and studying and stressful days and weeks, but I don't know, it's just a lot of rambling, but it's true. Don't be afraid to develop yourself. Don't be afraid to go further. Don't be afraid to try these things. There's more to life than, I love playing video games and being on my phone and doing all that stuff. I sincerely do. But I also love, learning. I love reading. I love studying. I still learn new stuff about math. I'm not done. You don't just hit a day and you're like, oh, I've learned it all. I don't need to go to school to learn that. I sometimes I thought about going back and doing my master's, even my PhD, and that seems really interesting. But at the point, I just like to kind of learn on my own now. I like to study. I like to read on my own. I really do like to pursue on my own, right? And there's something really special about that just didn't click with me when I was younger. It's very fulfilling. And that's it. I hated math in high school, and now I love it. It's something special. And maybe that takes time. I don't know. Maturity, time. I think it comes from personal drive and self-interest. When you live at home with mom and dad and it's not quite the same when you have teachers barking at you your whole life. It's not the same. It's kind of when you're set free and you're on your own, and then you really start asking yourself what you want to do and what you want to learn. That's for me when it started happening, when it was just me. And for a little while I was adrift. For a little while I screwed up. It was from screwing up and falling down and making mistakes and not caring that I developed an interest in, that's where it came from. It was really not hitting rock bottom, but hitting low points in my education and certain things, realizing I want to learn, and it's not just going to happen because if I sit there and just watch the teacher and just do the bare minimum and do the basics. If I want to learn, I have to go farther. I have to push myself. And that's the secret to education, not saying, well, I did what you said, I did I did that, give me the mark. That's not education, right? It's developing yourself and wanting more. So that's a lot of rambling. I don't know. It's just morning and I don't know. I'm trapped in my house like you. Maybe I'm losing my marbles. So hopefully you got something out of this lesson, and I'll talk to you later.